So your dryer's flashing that dreaded F7 code, right? And your clothes are just damp. It's super frustrating, I know. But don't worry, the solution is totally within reach. Think of this as a detective's guide. We're going to crack this case together, step by step, and get your dryer back to doing its job. So what's this F7 error actually telling you? Well, it's basically your dryer screaming, hey, there's a serious electrical problem in the heating system. The machine, being smart, has cut the power to the heat to stop a potential fire. It's a critical safety feature, and it's there for a very good reason, to protect you and your home. All right, here's our game plan for this investigation. First, we'll decode that F7 clue and talk safety. Then we'll meet the usual suspects, the parts that usually cause this. After that, we get hands-on with the investigation. We'll figure out if this is a DIY job or if you need to call in the pros. And finally, we'll cover how to stop this from ever happening again. Okay, let's dive right in. First up, understanding what we're dealing with and the absolute must-follow rules for staying safe. Okay, listen up, because this is the most important thing I'm going to say. Before you even think about touching a screwdriver, you must unplug the dryer from the wall. I'm not kidding. We're talking about a 240-volt circuit here. It's dangerous. Your safety is priority number one, so please, please make sure that thing is completely disconnected from power. So here are the 3 golden rules of this investigation. Rule 1, unplug the dryer. We just covered that, but it's worth repeating. Rule 2, trust but verify. Even after it's unplugged, grab your multimeter and double-check that there is absolutely zero power coming into the machine. And Rule 3, never, ever bypass any of the safety features. They exist for a reason, and that reason is to prevent a fire. All right, with this safety briefing out of the way, it's time to meet our prime suspects. Let's figure out who's most likely behind this F7 error. Take a look at this. The evidence points overwhelmingly to 2 main culprits, the thermal fuse or cutoff and the heating element itself. I mean, together they're responsible for about 70% of these cases. And that's actually great news because it tells us exactly where to start our search. And check this out. The control board, the really expensive brain of the dryer, it's the least likely cause. Whew. And this is why a proper investigation matters. A blown thermal fuse, we're talking maybe $5 to $15. A busted heating element, a bit more, maybe $40 to $80. But a failed control board, that can set you back hundreds. This really drives home why we don't just guess and start throwing parts at it. We gotta find the real culprit first. Okay, tools out, it's time for the interrogation. Let's walk through how to use your multimeter to question each of these components. So here's a key piece of evidence you need to understand. The entire heating circuit, the thermostats, the fuses, the element, they're all connected in a series. It's just like those old school holiday lights. If one bulb goes out, the whole string goes dark. It's the exact same principle here. If any single one of these parts fails, the whole circuit breaks and poof, no heat. That's why we have to check every single one. All right, let's go straight for our main suspect, the heating element. This is the component that does all the heavy lifting, and it's a very common point of failure. Okay, time to test it. Grab your multimeter and set it to measure resistance. That's the omega symbol for ohms. Now, touch the probes to the 2 terminals on the heating element. What you want to see is a reading somewhere between 10 and 30 ohms. That tells you the coil inside is good. If you see OL for open loop, or if it reads 0, well, the case is closed on this part. The element is bad and it has to be replaced. Now, for all the other suspects, the thermal fuses and thermostats. For these, you're going to use the continuity setting on your multimeter. It's the one that beeps. All you're doing is checking if there's a complete path for electricity to flow. So, a good part will give you a beep or a reading really close to 0. If you get silence or that OL reading again, that part is blown. It's done its job, sacrificed itself, and now it needs to be replaced. So, you've analyzed the evidence, you've found the broken part, now it's time to deliver the verdict. What's the sentence going to be? A DIY repair, or do you call in a pro? Okay, you cracked the case. You know it's wrong. So, now what? Let's break it down. Going the DIY route, you're definitely going to save some cash. We're talking parts only. But, and this is a big but, the risk is high because you're still messing with a 240-volt appliance. On the other hand, calling a pro costs more because you're paying for labor, but the risk to you is basically 0. Ultimately, this call comes down to you. How comfortable are you with this kind of work? What's your budget? And how quickly do you need it done?
Okay, case closed. But our job isn't done. The best detectives don't just solve crimes, they prevent them. So, let's talk about how to keep your dryer out of the repair shop for good.
You want to know the secret to preventing almost all of these failures? It's one word: airflow. The number one reason these parts blow is because heat gets trapped inside. That happens when the air can't get out, usually because of lint buildup. So the fix is ridiculously simple. Number one, clean your lint filter after every single load, not sometimes every time. Number two, once a year, give that entire dryer vent system a thorough cleaning all the way to the outside. It's a little bit of effort that will save you a massive headache and a bunch of money down the road. Look, at the end of the day, your dryer's health is totally in your hands. You now have the power to not only fix it, but to keep it from breaking in the first place. So I'll leave you with one final question to think about. Is your lint screen clean right now?